I guess just basically, like I said, more practice. It's going to be like a worksheet. It's going to be graded like a homework assignment. How it's going to work, so I'm going to do one, let you try one, and at the end, I'll let you guys work on a set, and whatever you don't get done, I'll do that, okay? It'll only be 4 problems. You probably would be able to finish in class. Let's go ahead and we'll see, though. I don't know. I'm not sure about that. All right, so we want to practice our factoring. And what we talked about yesterday is that you always start by taking out the greatest common factor, okay? So in this case, the biggest thing that goes into 4 and 36 is 4. And since this one only has 1x, I can only take out 1x. And then we just divide both of these terms by that greatest common factor. And then let's see what's left. So we have 4 and 4 once. X cubed divided by x leaves me with x squared. You just subtract the exponents. You want a move shot? And then 4 goes into 36 9 times, and then x divided by x is 1, but we don't need to write another times number. Then we're left with something with 2 terms, and when there's 2 terms, we use the strategy known as difference of squares, right? That's where you, well, maybe you may not be able to use it. Sometimes you can, but in this case we can. It is a difference, and these are 2 perfect squares. So the square root of x squared is x. And the square root of 9 is 3. One's plus and one's minus. So this was a double factoring situation. GCF, difference of squares. Okay. So every problem I do it for the group work here today that we're doing is going to be I do one, you do one, the one that you do is pretty similar to the one I give you. Then when I give you your final set at the end, you kind of get to decide what strategy to apply and when to apply it. So let's go ahead and throw another one here at you. That's for you. You guys go and see if you can get that. About a minute or 2 for it. See what you can pull off. All right. So what'd you get, Haley? Yeah. Okay. So, anybody need to see how or why? Okay. So let's move on to a different one here. Let's go ahead and take a look at number 3. Let's go and write that one down real quick. So this is one I'm going to do. I'll let you guys try one after. So in this case, no GCF, right? But we do have a difference of squares, so we'll start with that. Square root of x to the 4th is? Good. Square root of 81 is 9. Okay. Now in this case, we are left with 2 terms again in each set, which means it could only be a difference of squares, right? So is this a difference of squares? Yes, it is. Is this a difference of squares? The answer is no, because it's plus. Okay? So you're done. So last example was GCF with difference of squares. This example shows you how you could sometimes have 2 double sets of difference of squares in there. Okay? You got to watch out for the ones that are pluses because they look like the difference of squares, but they're not. So let me throw one of them at you. See what you can do with it. Okay, so Conacher, did you get this one? What did you get? Okay. Anybody got any questions for that one? Okay. So let's continue. So I like to start with difference of squares. They're the easiest, and then we'll take it up a notch here. The trinomials are kind of the pain in the butt here. So let's go ahead and do a trinomial. First of all, I want to see if there's any GCF. We can't take out any x's because the 16 does not have an x, and this one only has a coefficient of 1, so I can't take out any coefficients either. So there's no GCF. Okay, but it does have 3 terms, Anytime you've got 3 terms or 4 terms, you're going to start with the box method, but when you've got 3 terms, the way that that works is a little bit different than the one with 4 terms. When you have 3 terms, the first one goes here in the top left, the last one goes here in the bottom right, and 3 terms is harder because we're working with a lot less information than when we have 4 terms. So boils down to a guess and check situation. So what times what makes x to the 8? And just so you guys know, when you're doing a trinomial, they'll always break up evenly. So now technically you might think, well, x squared times x to the 6 would work, right? Won't work though. It's always going to break them up evenly. I'll tell you why in a second. So the only option here is x4, x4. Okay? Now what makes 16? Now keep in mind, look at my middle number I'm trying to get. You could say 4 and 4. That's not going to help. 16 and 1 is going to do it, right? Because we want 17, don't we? So let's throw a 16 here and a 1 here. Yes, you're right. I'm going to get to that in a second. Now, first of all, as Zanab just pointed out, this needs to be negative 17, so they both have to be negative, which means both of these have to be negative, right? Now, let's go back to the question. Remember how I said that these both have to be the same? If they weren't, then these would not be like terms, and you would not be able to combine them. So that's why that one always has to break up evenly. Now, when you're doing the one with 4 terms and you fill in all 4 boxes, they don't break up evenly. That's different, but you don't have. It's not a guess and check thing, so that one's different. But when it comes to the ones with 3 terms, when you break up that first one, those powers have to break up evenly. All right, so there's our first step, is you do the box, okay? Now, I'm not done yet. And the reason I'm not done is because these have 2 terms. And when you have 2 terms, you have to check to see if it's a difference of squares. Is this a difference of squares? Yes, it is. So it's going to be x squared minus 4, x squared plus 4. Is this a difference of squares? Yes, it is. X squared plus 1, x squared minus 1. We're not necessarily done. We've got to check to see if we have difference of squares again. Is this a difference of squares? Yes, it is. X minus 2, x plus 2. This one is not a difference of squares because it's plus. Same thing here. But that last one, that's another difference of squares. So it breaks up again. At this point, there's no more differences of squares, so we're all done. Okay? So we started off with the box because it had 3 terms, and it turned out we had some difference of squares after that. All right? Can I erase? No. No? A little bit longer? Oh. I'll leave it. I'm going to just go to the next problem though, but here's yours. So you guys try. Probably a pretty similar outcome you can expect. Go ahead and see what you can do. Jason, did you get to a final answer? Nick Smith, did you get to a final answer? What did you get?
I got the whole like factor number.
Yeah, final answer.
X squared plus 4.
Okay.
And then x plus 2.
Okay.
X minus 2. X squared plus 2. And then x squared minus 2.
That'll work. Okay. So first of all, now you may not have them in this order, but that's okay. So long as you have all, 5 of those factors, then you're good. So first of all, of course the hard part is the box method because you got to guess and check the right numbers here. So told you this would split up evenly, right? Now, a few of you guys go immediately to 8 times 8, and that makes sense. That's the most common way to get 64. But the problem is if you put 8 here and 8 here, you're going to get 2 8s here and here, and 2 8s do not make the middle, right? So it's not going to be 8 and 8. And then finding the right pair is a little bit tricky, but it turns out that it is 4 and 16, because that also makes 64, and it just so happens that 4 and 16 also make 20 when you add them together, We want it to be a negative 20 though, so they both need to be negative. And so what we end up with then is two different sets of difference of squares. So this guy here, oops, 4. This one here broke up into all this stuff. And then this one here, actually I think I did that wrong. Hold on. Let's see, which one went where? This guy is the one that broke up into x squared plus 4, and then x squared minus 4, then the x squared minus 4 broke up some more. This one broke up into these two, and that's it. Now, this one, I saw one student had written his answer like this, and it's not wrong, it's right, but I think it's okay to say that whenever you can't take a square root of the number, just leave it. But that's technically right. There's nothing wrong with that. Okay? But I think this is fine. We'll leave it. Okay. Let's go ahead and take a look at another one. So once again, we're looking for greatest common factors here, right? No GCF. 4 terms. We go immediately to the box, right? Top left, first term. Last term, bottom right. The other two, it doesn't really matter where they go, just so long as they go in the box somewhere in the remaining spaces. Now, on this one, we don't guess and check. Since we have all 4 spaces, what we do is we factor out what each row and column has in common. And that way we don't have to guess and check. We can just kind of get it. So here, these two, this row, those 2 terms in that row have an x to the 4th in common. In this row, first of all, they're both negative. Other than that, they really don't have anything in common, so we put a 1 there. Because at least they can both be divided by 1. In this particular column here, they both have 2 x's in common. And in this column, they both have a 4 in common. But it's a positive 4. So here we go. So we have x to the 4th minus 1 down the side there, and then x squared plus 4 along the top, and we have a difference of squares again. And we have another difference of squares after that. The last two are not differences of squares because they're both pluses. So we're done. All right. This looks way too similar, so I think I'm going to go ahead and skip that one. We'll go ahead and skip 8, you guys. Let's go ahead and do another one here. Can I erase this? I think what I'm going to do is I'm going to skip 8. I'm going to do 9, and then let you guys do 10, and after that we'll set you loose on your problems here. I'm going to skip 8, yeah. So just number 8, just leave it blank. Because the reason I want to skip 8 is it's almost identical to 7, so it'd just be kind of a waste of time. Okay, let's do this one. What do we do first here? Well, once again, we always check for a GCF. So in this case, we do have a greatest common factor. I can take out an x, right? And that's going to reduce every power by 1 now. And now what's left here on the inside has 4 terms. So we use our box method again. The example I'm going to give you in a second will be pretty similar to this one, I think. Okay. Huh? All right. So what do these two have in common? Square. These two, I can take out a 5. That's about it. Here, I can take out a 4. And then down here, we can take out a 25. 25 goes into both of those numbers. But you guys notice something funny here? What's the funny thing? There's some negatives, right? So what do? Where? On both of them. Why? So this is, remember how I said before when you're doing the GCF thing, if they're both negative, then you take out a negative, right? But in this case, that didn't happen. The reason for that is because when they're both negative, this guy comes out positive, but these two will come out negative. So that's another case where you got to watch your signs, okay? But there it is. So now we have x4 minus 25 and x2 minus 5. And don't forget about this guy. That's still part of our answer, that GCF we took out in the beginning. Don't forget about that one. It's easy to forget about. Anyway, this one's a difference of squares. So we can do x squared minus 5, x squared plus 5. And then we have this guy here, which is, you could do the difference of squares on it, but it's not necessary. Now I want to show you guys another way you can write your answer here. Do you notice how one of them is repeated? Okay, so we call that a repeated factor. And whenever you try to find roots, we call it a repeated root. But anyway, how it might look on the test is like this. I don't know for sure. Oops. How they'll write it, because it could be written in different ways. But instead of writing it twice, they just might put a square there. Okay? Just so you guys know. So, on this one, we had 3 factoring techniques: GCF, box, and difference of squares. So if you can handle a problem like that, especially with like a trinomial one, you're good. You're set. Okay? So let me give you guys a problem set now to do. Well, let me give you one that's like this one first, and then I'll just set you loose on a couple to do on your own for the rest of the block, okay? And whatever you don't get done in class, you can take home and do. But here's one for you. It's kind of like the one I just did. See what you guys can do.
X squared, parentheses, x squared plus 3, and then x plus 2.
That's it. This one didn't have any differences of squares on it or anything, so that was a pretty shortcut. All right, so that's the end of our together work, and now I'm just going to set you guys loose on the last 4 problems. See if I can zoom in on these somehow, make them a little bit bigger. It'll be on Google Classroom if you don't finish in class today. This one. I wonder if I can change the view a little bit. This. All right, let's go ahead and just write them down. It's kind of hard for me to display them all at once. So go ahead and write down number 11 there, please. Write down number 11. You guys good? All right, I'm going to go to the last 3 there. Where did it go? Oh, cool. All right, there's 12 through 14. So looks like this one's a little bit difficult to see, though. Where's the rest of 14? Dang it. Booty. All right. Different strategy here. There's 12 and 13. And then there's 14. So I'll collect those from you guys tomorrow. But in the meantime, if anybody did their homework last night and you want to turn that one in today, I'll take it. But since it's a Wednesday, I won't be uptight about it. You could turn it in tomorrow if you want to. But if you have last night's homework and you want to pass it up now, now's a good time.